day everyone, my name is Tarusaran, son of Ramesh. I am coming from DAD2 and my matrix number is 01DAD20F2007. So today I am here to present about differentiation. I am not alone in this presentation. I have accompanied by 3 friends together with me, and I will introduce them with their roles and responsibilities together. Okay, first Muhammad Ikhwan, who will be solving all the problems. Second, Daniel Rashid will be editing the slides. Third, Harishankar will be helping Muhammad Ikhwan in solving the problems, and me as editor will be helping Daniel Rashid to edit the slides. Introduction of differentiation. Differentiation is used widely in solving problems. When we find the rate of change of a quantity with respect to another quantity, we are actually doing differentiation. Another name for differentiation is the derivative of the function.
Hi, basic rule of differentiation. If y equal x power of 1, dy over dx equal to 1 x power of 0 equal 1. If y equal to x power of 2, dy over dx equal to x power of 1 equal 2x. If y equal x power of 3, dy over dx equal 3x power of 2. Example of application of differentiation in real life: to calculate the profit and loss in business using graph, to check the temperature variation, to determine the speed or distance covered such as mile per hour, kilometer per hour. Differentiation are used to derive many equations in physics. In the study of seismology, like to find the range of magnitude of the earthquake.
Before we see the solutions, now is the time to see the questions. Okay. Given y equals to 2x power of 2 minus 3x power of 2 minus 12x plus 11 represents a curved line. A. Determine the coordinate of the stationary points of the curved line. B. Determine the nature of the stationary points. C. Sketch the graph of the curve.
So the first question is determine the coordinates of the stationary points of the curved line. Given our function is y equals to 2x cubed minus 3x squared minus 12x minus 11. Remember, to find the coordinates of any stationary points, we followed the 3 steps method. That was step 1. We need to find the derivative function that find dy dx. Well, given our function is y equals to 2x cubed minus 3x squared minus 12x plus 11. We use the power rule of differentiation to find the derivative function, and doing so we find the following: 6x squared minus 6x minus 12. Step 1 done, and we move on to step 2. In step 2, remember, we need to solve dy dx equals to 0. In other words, we are looking for the values of x at which the derivative is equals to 0. Since those will be the x coordinates of any stationary point this curve have. Now using the factor dy dx equals to 6x squared minus 6x minus 12, solving dy dx equals to 0 means we have to solve 6x squared minus 6x minus 12. Now you can use calculator to solve this quadratical equation. Alternatively, you can solve by the hand the follows. We notice we can divide throughout 6 and state that this equation has the same solution as x squared minus x minus 12 equals to 0. We can rewrite this quadratic in factor form x minus 2 times x plus 1 equals to 0 if either x minus 2 equals to 0 or x plus 1 equals to 0. Thus x equals to 2 or x equals to negative 1. And now we have two solutions to dy dx equals to 0. Since there are two values of x, it means this function have two stationary points and there are x coordinates of stationary points. Now we move to step 3. Calculate the y coordinates of stationary points. Since this function has two stationary points, one x equals to 2, the other x equals to negative 1. We have to calculate two different y coordinates, and we do so using the regional function. So that start with the stationary point with x coordinate x equals to 2. The y coordinate will be y equals to 2 times 2 cube minus 3 times 2 square minus 12 times 2 plus 11. Y equals to negative 9. So the first coordinate is 2, negative 9. When the x equals to negative 1, y equals to 2 times negative 1 cube minus 3 times negative 1 square minus 12 times negative 1 plus 11. Y equals to 18. The second coordinate is negative 1, 18.
So for the next question, we have to determine the nature of the stationary points, or we can call it a turning point. What does it mean by this question is, we have to prove either the coordinate that we got from the question A is a maximum turning point or a minimum turning point. So for us to solving this question, we have to use the second degree differentiation. Second degree differentiation is where you differentiate again your dy over dx equation, and we label it as a d square y over dx square. So from our question, our dy over dx is a 6x square minus 6x minus 12, and after we differentiate it again, we got 12x minus 6, and then we have to substitute the values of x from question A into our d square y over dx square equation. So our first x is 2. After we substitute it into our d square y over dx square equation, we got 18. So how do we know if it's a maximum turning point or a minimum turning point? Take a look at the top right here. If your d square y over dx square equation is bigger than 0 or a positive number, it is a minimum turning point. But if your d square y over dx square equation is smaller than 0, it is a maximum turning point. And if your d square y over dx square is equals to 0, it is a point of inflection. So from this, we know that a coordinate 2, negative 9 is a minimum turning point because 18 is a positive number. And next, our second x is a negative 1. After we substitute it into our d square y over dx square equation, we got negative 18. So from this, we know that the coordinate negative 1, 18 is a maximum turning point because negative 18 is a negative number. And for the last question, we have to sketch the graph of the curve. To do this, we have to substitute all the value of x in the y equation into 0. And our y equation is 2x power of 3 minus 3x square minus 12x plus 11. This will be resulted our coordinate to be 0, 11. After we got all our coordinate, we just have to sketch our graph like normal. I hope with our explanation you will find answering and understanding the question of derivative more easily.
Summary: the derivative is the first of the two main tools of calculus, the second being the integral. The derivative is the instantaneous rate of change of a function at a point in its domain. This is the same thing as the slope of the tangent line to the graph of the function at that point. Thank you.